Welcome back to the wonderful world of algebra. Today we are going to do sections 1.5 to 1.7 in your book, and there's going to be a bunch more vocabulary with this. So the first word is square root. And the square root is basically what number times itself gives you the number underneath the square root sign. So that would be 3. Now, this means that 3 times 3 gives you 9. Well, also, -3 times -3 gives you 9. So when you're taking the square root, it can be +3 and it can also be -3. And you can write that as plus or minus 3. So square roots actually have two solutions. The square root sign, if this makes any sense, is the same exact thing as 9 to the 1/2 power. There's like a little 2 right here. It's a square root. Later in the year, we'll get into different roots. But every positive number has 2 square roots. So what would the square root of 16 be? Think. That would be positive or -4. What about the negative square root of 100? And that would be -10. And then the square root of 100 would just be positive or -10. And the square root of -49 is impossible because no two numbers of the same sign will equal this negative right here. So if you said it was -7, well, -7 times -7 is +49. So that will not work. So when you have a negative underneath, that is no solution. It's actually an imaginary number, which we will also get to later in the year, but do not fear right this second. All right, the next section, 1.6, has to do with order of operations. Do you remember PEMDAS? Or please excuse my dear Aunt Sally? Or Paul eats many donuts after school? Whatever makes you remember this. Parentheses are first in order of operations. Then you go to exponents. Whoops. Oh my, hold on. Multiplication and division you're going to do from left to right. And then addition and subtraction you are going to do from left to right. And in fact, you might always want to make that plus a negative, the whole slash and dash thing, the additive inverse. It's a beautiful thing. So let me just give you a couple problems to do to see if you remember order of operations. 21 minus x plus 2 times 5 when x equals 7. Go ahead and pause. So multiplication and division from left to right means we would do this first. And then you have 21 minus 7 plus 10. I personally would make that plus a negative. 21 plus -7 is 14, and 14 plus 10 is 24. How'd you do? We'll do another. 5 squared times 30 minus x when x is equal to 24. Go ahead and pause. All right, please excuse my dear Aunt Sally, says parentheses first. So this would be a 6. So you have 5 squared times 6. Please excuse exponents is second. So now you have 25 times 6. And if you have 6 quarters, you have $1.50. So 25 times 6 is 150. Let's try a couple more. I'll give you 3. -22 minus 2 squared over 5 minus 3. 10 minus 5 squared, absolute value, divided by 5. Absolute value, you're going to think of like parentheses. And 3 square root 50 minus 1. You're also going to think of square roots as parentheses. Go ahead and pause. When you have them done, come on back. In the first one, when you have a big division sign, the entire numerator is grouped together and the entire denominator is grouped together. That's pretty important. I should have said that before pause. So in the top parentheses, and every time you have a big division sign, just put the parentheses in. So the 2 squared would be the first step. So you're going to have negative 22 minus 4 over 5 minus 3. And you're still going to do the whole top and then the whole bottom. It's like this parentheses grouped. Whenever you have a minus, slash and dash will help you become happier in life. So now you have negative 26 is the numerator, and we can go ahead and put the denominator together as well. Denominator on the bottom, that is 2. And negative 26 over 2 is negative 13. So that is your final answer. In the second one, parentheses comes first, so we're going to do what's inside the absolute value. Inside the absolute value is a squared term, so that needs to be first. So we have the absolute value of 10 minus 25 divided by 5. Well, slash and dash, 10 minus 25 is negative 15, and absolute value is a measure of distance. So this is 15. It always makes everything positive. It's 15 away from 0 on the number line. And then 15 divided by 5 is 3. So positive 3 is your final solution. And in the last one, under the square root, it is also thought of as a parentheses. So 3 and then the square root of 49. The square root of 49 is both positive and negative 7. So you have 3 times positive or negative 7. So your answer is actually positive or negative 21. You have 2 solutions. You can list those separately or like that. Gotta love, please excuse my dear Aunt Sally. Order of operations is the key to life. 1.7 is our next and last section. This has some more really juicy vocabulary. So, commutative property. I like to think of it as taking a commuter train. So if you go from Lansing to Jackson, you would then go from Jackson to Lansing, if that makes any sort of sense at all. You can do this with the commutative property of addition as well as the commutative property of multiplication. So basically you just flip your letters or your numbers. This could be done with numbers too. So 1 plus 2 is the same thing as 2 plus 1, and 1 times 2 is the same thing as 2 times 1. Commutative property. Associative property is whoever you associate yourself with is kind of what you become. So this time you're going to have 3 terms, and again, this is with addition or multiplication. And if you 3 peeps are friends, it doesn't matter if you group the A and the B or if you group the B and the C. Your association is going to be the same because essentially you're all associated together. And this is the same exact thing with multiplication. The parentheses of the first 2 is the same solution as the parentheses of the last 2. You can do this with numbers as well. We could do 1 plus 2 plus 3 is the exact same thing as 1 plus 2 plus 3. And with multiplication, 1 times 2 times 3 is the exact same thing as 1 times 2 times 3 first. Done. Yay. Hooray. Well, let's practice this actually, and then there is another property. I'll give you 3 problems to practice. 15 1/3 plus 4 plus 1 2/3. Problem number 2, 40 plus 58 plus 90 plus 2. And problem number 3, 1/2 times 7 times 8. Go ahead and pause. Okay, so hopefully you grouped these two together first because 15 plus 1 is 16 and 1/3 plus 2/3 is 1 whole. So that would be 17. So it's a lot easier if you see two numbers that you can easily put together to put those together first. And then when you add the 4, you would get 21. In the second one, the easier numbers to group are 58 and 2. That would give you 60. And then 90 and 40 would give you 130. And then 130 plus 160 is 90. You can do it the other way. This is just easier without a calculator, more mental math. In the last one, probably you're going to want to multiply the 8 and the 1/2 first because it'll make it a little smaller. And then 4 times 7 is 28. Isn't it great to be back in school? All right, next, property distributive. So, if you have a number or a letter outside of a parentheses, you take that, a number next to a parentheses, this means multiplication, and you multiply it through to each thing in the parentheses. This would be separated by a plus or a minus. This doesn't work if everything's multiplication. So this is AB plus AC. Let's try that with numbers. So 5 times x plus 10. And you did touch on this last year a tiny bit, would be 5x plus 50. All right, so what if you had to multiply 15 times 103 without a calculator? You could do it the long way where you do 103 times 15, but it's actually easier to break 103 up to 100 plus 3. And then 15 times 100 is 1500. 15 times 3 is 45. So this is 1545. You would get the same answer with that, but this is way more fun and should make you smile. So let me give you one to practice. 6 times 19. Go ahead and break it up just like we did. Hit pause. So hopefully you broke this up into 6 times 10 plus 9. And that would be 60 plus 54, and that is 114. Again, you can do the traditional method of 19 times 6, 6 times 9 is 54, 6 times 1 is 6, plus 5 is 11, and get the same thing. You know, look inside and see what you like better. Okay, 3 more vocabulary words and 3 more problems, maybe 4. Like terms. So this is when you have the same variable. That means letter, raised to the same power. That you basically combine them. So if you had something like 4x plus 3x, those are like terms, same letter, same power. There's no power up here. So 4x plus 3x means you have 7 x's. If you had a 2x squared plus a 6x squared, same letter, same power, so you would just add these numbers. 6 plus 2 is 8x squared. So when you're adding, you have to have like terms, and whatever you add, the like term is the answer. Ooh, if that makes sense. And then the number of terms, you have to put all of your like terms together first. So if you had something like 3x squared plus 2y plus 7xy plus 5, none of these have the same letters. So none of these are like terms. So this is a term separated by a plus. This is a term separated by a plus. This is a term separated by a plus. And this is a term separated by a plus. So this problem has 4 terms. And the biggest x coefficient is an x squared. So it's actually an x squared term. If you have something like x plus 3, this has two terms. It has the x term and the number term. If you have something like 2x plus 6x plus 5y plus 7, you would need to put the like terms together before you think about how many terms there are total. So 6x and 2x is 8x, same letter. You have the 5y and the 7, one term, two term, three term. That's your answer. So a term is each, we'll call it element, separated by a plus or a minus after putting like terms together. And the last vocabulary for this beautiful day is going to be coefficient. And that is the number in front of the variable. That's the letter. So if we go back up, so the coefficient of x is 8. The coefficient of y is 5. It's just the number in front. If there was just a letter like this, x plus 3, the coefficient of that is 1, because you can always put a 1 in front of a letter and nothing changes. All right. Your problem to try right now is I'm going to draw a four-sided figure. This has sides x, x plus 2, 4x, and 2x minus 6. Write the perimeter, the number of terms, and the coefficient of x. If you're stuck, the perimeter is adding up all the sides. So it would be x plus 2, it doesn't matter the order, plus 2x minus 6. We could make that plus a negative 6. And 4x. In fact, you should make it plus a negative 6. So if you want to hit pause, go for it. If you're thinking you're confused, I'm going to put a 1 in front of the x's that are alone. So for like terms, you have a 1x, another 1x, 2x so far, a 2x, that brings us up to 4x, and a 4x, which gives you 8x. And then for the numbers, you have a 2 and a negative 6, that's a negative 4. So this has two terms, and the coefficient of x is 8. Let's try another one. $3p, $10p, $20p plus 1. Another triangle with an m, an m squared, and an m cubed. Go ahead and hit pause. So you have 3p plus 10p plus 20p plus 1. 3p plus 10. Actually, I'm going to do the 10 and the 20 first. They're easier to group. That's 30. And then 30 plus the 3 is 33p. That's that associative property. And then the 1 hangs out on its own. So 33p plus 1 is your answer. That's two terms. And 33 is the coefficient. Leading coefficient is what it's called. In the next one, we are just adding m, the m squared, and the m cubed. If you put m to the 6, you fell for the trick. None of these are like terms. Each m has a different power. So this is actually 3 terms. And it's best to write the biggest exponent first. And the coefficient of all of these is 1. All right. I think that's all for today. I hope you are just feeling invigorated and the love of math is eminent in your whole house. Have a lovely evening.